Anna, hi, how are you?
I'm pretty good. How are you?
I'm pretty good. I'm
Can you
really
hear?
glad to see you again at NodeConf. It's we've been seeing each other, we've been bumping into each other like this for a few years now.
Yeah,
So
it's good to be back.
great to have you. So you've been one of the most active contributors to the Node.js core over the last 4 years, and I understand you're now working with MongoDB.
Right, yeah, I've been with MongoDB for about a year now, and yeah, pretty happy with that.
Oh, that's great. So I'm going to hand over to you now so you can teach us how to build a database shell from scratch.
All right, thank you. Cool. So yeah, hi everybody. I'm Anna, and yeah, so that is what I actually want to talk about. So first of all, a bit about who I am. So I'm Anna. I use ADDALEAX as my handle almost everywhere, including on Twitter, where I already posted a link to the slides if you want to look anything up later. And yeah, so I have worked a lot on MongoDB, and I'm gonna mention what exactly that is in a second. And yeah, formally, I've been on the Node.js TC, done a lot of work on Node.js core in the past. Not so much anymore, but I'm still generally around there. And yeah, so first of all, I want to mention this is not a product talk. I mean, like, I will be talking about MongoDB things, but that's just because I worked there. Those are the things I've built. But you know, you could imagine any person from a SQL database company doing the exact same talk, basically. And yeah, so let's jump into it. So what is MongoDB? MongoDB is the shell for MongoDB. And so if you've worked with MongoDB in the past, you might know that there was or is this Mongo shell that you probably have encountered at some point. And this is a replacement for that is hopefully a bit prettier. You can see all that nice coloring here, but also hopefully a lot more extensible, more maintainable, and yeah, generally just better, of course, than before. And so, yeah, so why are we doing this? First of all, Node.js is cool. You can build a ton of cool stuff upon Node.js. It is much easier to maintain than a C++ application, which is what the Mongo legacy shell was. And it offers so many benefits, honestly. We have the additional advantage that what people will write is closer to what they're actually developing. It's like previously, so like there's a Node.js driver, which is what we call the libraries that you can use to connect to MongoDB. And there were some discrepancies between the Node.js driver and the legacy shell, where like you would write JavaScript in both cases, but it would be different JavaScript, which doesn't really make any sense from a user perspective. So we're cleaning that up, aligning ourselves a bit closer to what the Node.js tooling for MongoDB is doing anyway. One huge factor that allows that we get out of building this new shell is we can actually use all existing NPM packages for building this application, which, I mean, everybody who's listening has used NPM packages at some point and knows how much work that can potentially save for you. And one additional nice thing that we get out of this is that actually you as a user of the shell can use all existing NPM packages. You can require Node.js modules from inside the shell, which exists the millions and millions of packages that are already existing, which is pretty awesome. We can do more. We built the shell in a way that it is possible to have multiple different front ends for the shell. There's a CLI, of course, which is replacing the legacy shell, but also, for example, there's a React variant. This is embedded in our Electron application that we also have, the GUI for MongoDB Compass. And it works the exact same way. It's just like, it's a bit nicer, it's a bit more integrated with the GUI. And yeah, that's pretty cool. And there's also a Java variant. I don't have a screenshot for that, but so JetBrains is using that in their product as like a way to embed our Mongo shell into their application, which is possible because there's JavaScript interpreters for Java. It also powers, it is the backend for the MongoDB VS Code extension. So like, if you don't have to have used this in the past, but the general idea is in the VS Code extension, you can create these playgrounds, as they're called, which are scripts that you can write that use the shell syntax, and you can run them. And essentially they're being run as if they were like input as one big input line for a shell. So that's pretty cool. We can use this modular layout to power all the products that we maintain. One thing that I particularly like is that you can actually use the shell without ever having installed anything. You can just use npx mongosh and then specify whatever database you want to be connected to. And that works out of the box if you have npm installed. And yeah, so we get a ton of features from using Node.js. So the CLI, for example, builds upon the Node.js repo, which, there is an API to use that for your own application. And for example, we get the same kind of auto-completion that you would get in the Node.js CLI. So yeah, all around, pretty happy with this decision. And yeah, I want to talk about some problems that we ran into while doing this and how we solved them. So one thing, I'm going to go through this a bit faster because last year, actually, Irina Shestak also gave a talk about this here. But one thing is, we want to ship the shell as a single binary. That's nice for a couple of reasons. It's nice for the same reasons that Node.js itself ships as a single binary. And yeah, we want to have that too. And obviously, people have come up with really good solutions for this so far. There's PKG, there's Nexi. Unfortunately, both of these didn't quite do what we wanted at the time because we had a couple goals. We wanted to sign up binaries for macOS. That turned out to be a bit tricky with those. We wanted to have limited size. So for example, with Nexi, we got things to work mostly, but the binary it generated was huge in that case, and we didn't really want to do that. We have the need to support unusual architectures because MongoDB is used in a lot of different environments. So for example, this includes like S390X, so the Z-series IBM machines or PowerPC, that kind of fun stuff. and we wanted to include native add-ons in the bundled binary, which to our knowledge, nobody had done before. And so yeah, so that is how we came up with BoxNode, which is like, the idea is you take a JavaScript file, you take a Node.js version, and you put the two together and ship it in a box. It checked off all the points on that list. It uses the Node.js C++ embedder API to achieve that. And there's one big downside to doing this, which is it needs to compile Node.js from source. No way around that, especially if we want to include native add-ons. But overall, we're very, very happy with that. So, second problem. And it is awesome that Node.js is generally an async I/O library, but this actually poses a problem for us. So if you look at this thing that a user might enter at some point in the shell, this db.test.find1, if this were SQL, it could be select star from test limit 1. So like it is not important that this is like with the syntax that MongoDB uses. What's interesting is this returns a JavaScript object and you can access properties like that. So there's this .a in the second line that gets you the value of that property. And if you think about this, like how would you implement this? Obviously, this is like a database that you connect to over network connection. And there's no way to do synchronous network I/O in Node.js. So yeah, I actually kind of stuck with this problem where like db.test.find1 is not really something that you can implement in a synchronous way. How do we make it so that this property access on the result works without any kind of inserting a weight or anything like that? And well, so let's jump to the solution for this. So first, two quick reminders. One, what does this function return? Async function, return 42. I think most of you will know, but it does not return 42. It returns a promise that eventually resolves to 42. That distinction is going to matter in a second. And also, like, if you have not ever worked with the comma operator, it's a fun piece of JavaScript. So this expression, for example, where you have two strings in brackets separated by commas, it will always just evaluate to the last expression of that list. So in this type, in this case, the string GHI. All right, so we're doing some rewriting of the input. We actually start out by taking the user input and turning everything that is not inside a function into an iffy, immediately invoked function expression. Just makes the rest of the transformation that are coming a bit easier, because then every code is in a function and we can do the same transformations for all functions. Then second step, we take this iffy, we actually turn it into an async function. And we we do some funky stuff with the comma operator. We take every single expression in the input and we store it in a temporary variable, which is this underscore ex thing, which just stands for expression. And then we check, is this something that should implicitly be awaited or not? And if it is, then we await it. If not, then not. This is how we implement this implicit awaiting thing. Now, the problem with this is that this is now an async function. It is different from what we had as an input, because this returns a promise, and if this, for example, if the input were a synchronous function, like I don't know, return a plus b, then it should not have been turned into an async function. And well, there's a third step, and I'm not going to go into detail on all of this. If you find this interesting, which I hope you do, which I mean, I'm talking about it because I think it's interesting, then feel free to look at the slides later. But the general idea is that actually there is a way to take an async function, and if it returns synchronously, also wrap it in a way that the wrapper function returns synchronously. And if it returns asynchronously, also make it return asynchronously. So basically something that takes this code, async function return 42, and wraps it in a way so that the wrapper function also returns 42 immediately and not only as a promise. And we do that by keeping track of which state the function is currently in. Like, is this still in the synchronous execution phase, or have we already encountered some await, or has this thrown an exception, something like that. And yeah, and so if this was something that happened to be, a function that was previously synchronous and we turned it into an async function, now we're doing this wrapping, then at the end you can see this mark as should await thing, which takes the promise return from the async functions, marks it in a way so that this promise, we keep track of which promises should actually implicitly be awaited and which not. And then if it is used somewhere else, then it falls under this should await case on the left-hand side. Again, like, don't overthink it too much right now. I just, I shared the link to the slides, and that's how you can look at it. This is the order of execution in the different cases. So like this would be the synchronous case, this would be the asynchronous case. So yeah, at the end of the day, we just do a Babel transformation that allows us to do this the right way, and that just kind of saves the day for us. And pretty happy with that. I actually gave a talk about this problem, specifically about the synchronous I/O problem in Node.js earlier this year. There's a couple other solutions that you can do that all kind of like are not what we want to for reasons, but that generally allow you to do synchronous I/O in Node.js. So like the most popular one, I guess, would be using workers together with atomics, which allow you to wait for an operation to happen in a worker synchronously. All right. Do our users actually care that this is happening under the hood? No, they do not care at all. I'm just sharing this again because I think it's interesting. And yeah, we sometimes have people who find out about this kind of thing asking, what is an async rewriter? And sometimes we we explain what that is, but yeah, no, it's all working very well. There's very little, it's not a leaky abstraction. And the third problem that I want to mention is, users have way more backwards compatibility needs than we would want them to have. So this is, again, it's a replacement. It's a drop-in replacement for the legacy shell that we provided. And so people expect things to work the same way, even if it includes things like undocumented APIs, because they were using that. And well, we're not really fond of the idea of implementing undocumented APIs or in cases where JavaScript build-ins were extended with custom methods, which I think it's 2021 and everybody has learned that that's not a great idea. But yeah, so this is something that happens, and our solution is, of course, build a package manager, because that is always the easiest thing to do. I mean, obviously I'm being sarcastic, just to be clear. But yeah, we kind of build a package manager in some way. And so you can actually do this. You can run commands in the shell that says the package manager is called snippet. You can run snippet install Mongo compat, and then it installs a snippet. You can say, yes, I want to load this right now into the shell that I'm running already. And then you can do things like array.sum, which is one of the ways in which the legacy shell expanded JavaScript build-ins, which, again, please don't do that. But I guess if you have legacy code that relies on this kind of thing, it's nice if it keeps working, at least for a while, until you have the time to migrate your stuff to cleaner APIs. And so how does this work under the hood? So there's 4 actors, basically. We have the shell, the snippet package manager running in the shell on the left. We have a GitHub monorepo where all the snippets that we currently have are stored. We have the or a NPM registry that the shell interacts with, and an index file that lists all the snippets that are currently available. And so first step is, so whenever something is changed in this GitHub monorepo, for example, a new snippet is added or one is modified, then 2 things happen. 1, the index file is updated, and 2, we publish those to the NPM registry. And then what happens at shell startup is it fetches this index file from the same location where the GitHub monorepo put it, basically. And we see what the snippets are that a user could potentially install. We just keep that in mind. We're currently doing that as a single file because we're not expecting there to be too many snippets, and in the sense that it would be unfeasible to maintain it as a single file. And this is just the easiest way that we can do it right now. And so then if a user says install something, then the index file actually contains a mapping from this name, for example, Mongo compat in the example that I showed, to an NPM package name. In this case, it's all scoped under @mongo.sh so that we're not polluting any namespaces. And it uses an internal NPM client, so that we basically download NPM for you if you don't already have it installed into a temporary directory, and use that to install this file or this package. I mean, it can depend on other packages. For example, we also have one where we're doing schema analysis on your databases or your collections. And that uses existing NPM packages that do that and just integrate it in the shell a bit more nicely. And yeah, that's actually already it. I have uploaded the slides again if you're interested in reading up on anything. And if you have any questions, feel free to reach out in any way. I'm always available on Twitter if you want. Yeah, I think that's it.
Thank you, Anna. Thank you very much. That was a great talk, and you've blown many people's minds with the async rewriter, because yes, there was a lot of reaction to that. So, and I totally feel the pain of backwards compatibility with undocumented APIs. You just have to leave one backdoor open, and somebody's going to be exploiting that. So I do have some questions for you. So Matteo has asked, are these slides the only place where we can read about the magic that you have implemented to achieve the sync input-output?
The async rewriter he was asking about, right?
Yeah.
So I mean, everything we do is open source, and obviously this is like also something that was kind of tricky to implement. So we do have pretty good internal documentation that, as an open source project, is public. Also, just because at some point somebody new might have to learn how to maintain this. And so, yeah, there's MongoSH is maintained in a monorepo. You can just look that up, but I think it's just github/mongodb.js/MongoSH. And monorepo means, okay, there's packages/async rewriter, and the README has a lot of details on how exactly this works also.
Okay, cool. Thank you. He did have a follow-up question. He just said, if it can do this, why can't the official repo do the same?
The official repo? I'm not sure what he's referring to.
Okay, well, maybe he can reach out to you on Twitter and ask there, because maybe I'm just asking it in the wrong way. Okay. I do have another question. Could you share more about the embedding Node.js into itself concept you mentioned?
Right. So this was something that I played around with early this year, at the end of last year. So, I mean, one thing that you can do in Node.js, you can embed it into other applications. One way that Node.js embeds into itself is worker threads. You create a new thread and then you start Node.js instances there. And, conceptually, there's nothing speaking against doing that on the same thread. So what you can do is you can start a new Node.js instance with its own event loop on the main thread of your Node.js application, and then just say, hey, I want to fetch something. I want to get some data from an HTTP server or something, and just say, hey, please run this inner event loop for as long as it takes to, resolve that promise. And then you have something that's synchronously, from the perspective of the outer event loop, does network I/O. So this is very experimental. It's just something that I played around with. But if you're interested, there's a native add-on called Synchronous-Worker that you can take a look at. And yeah. So,
okay, cool. Thank you.
Feel free
You have to excuse me. I keep on looking over here because there's a lot of chat going on, and I'm trying to make sure I don't miss any questions. So if anybody does have a question, please do put it in the chat. That's why I keep looking down to try and see what the questions are. So what about this one? So what is the most interesting way in which using Node.js has benefited your users?
It's a good question. So one thing that happened recently, so I mentioned that the shell is actually powering as a backend the VS Code extension. And so somebody asked, hey, so is there some way in which I could get a desktop notification if my script has finished running, which, like, if the script is a very time-consuming script, you might want to do that. And so I mean, it's not super trivial to do that, but one thing that you can do if you're happy with the solution is you can use the Node.js child process API to call whatever operating system command line interface there is for creating notifications. And so actually, you can kind of do that very easily if you're okay with an OS-specific solution. And that was really cool to see.
Sounds awesome. Well, Anna, it has been delightful to see you as ever. I'm hoping we can get to see you in person next year. So thank you very much for your talk, and I'm going to wave you off. Thank you.
All right. Thank you for
There she goes. Bye.
See you.